Okay, so today we're going to be covering section 1.3, which is all about simple random sampling. Here we go. Well, it turns out when you're actually wanting to gather information about a population, if you can't ask everybody in the population, then randomness in your sample is important. As kind of a dumb for instance, if I wanted to know, say, the average BMI of a Japanese citizen, should I just ask sumos? That would probably not work out so well for me. In a similar manner, maybe I want to know about what percent of Americans like the Yankees or, approve or disapprove of the Yankees. Well, should I ask only Boston Red Sox fans? Well, absolutely not. Therefore, we want sufficient randomness in order to guarantee that we're getting somewhat of a good, reliable source of data as to what the actual population wants. You kind of want a mix of all opinions to get a little of everything. This leads us to want to define random sampling. Random sampling is the process of using chance to select individuals from a population to be included in the sample. When you are doing random sampling, every single individual has has a chance of being picked, an equal chance at that. Random sampling. I'm going to skip down to the third bullet point quick. Say that we need a sample of size lowercase n from a population of size capital N. We will say that the sample is a simple random sample if every possible sample of size n has an equally likely chance of occurring. Now let's just pause for a little bit because I just read some crazy definitions out there. Like I said, we want to have sufficient randomness. Now, random sampling, what I say right up here, literally just means that every individual has an equally likely chance of being picked. Okay, not a big deal. Now, what's the most random thing that you could think of when, say, you're at a family gathering and you need to pick 3 of your family members to do something? Well, one of the best ways you could probably do it would be to write everybody's name down, put it in a hat or a bucket, and draw 3 names at random. That's all simple random sampling is really meaning. A simple random sample just means that every group of the size of sample you're going for has an equally likely chance of occurring. So it's not like 3 ladies has a less likely chance than, say, 2 ladies, 1 guy, or something along that order. So simple random means every sample of size lowercase n has the same chance of happening. Importantly on this slide, notice that we are saying lowercase n is the number in the sample, whereas capital N is the number in the population. This will be, I guess this is what we'll use for the rest of the semester. Lowercase n will always be the number in the sample. Capital N will always be the number in the population. Going back to that second bullet point that I did not mention yet, and it's bold, so we may as well mention it. If convenience is used in a sample, the survey is meaningless. Turns out if you just ask your friends whether they like you or not, well, they're probably all going to say yes because they're your friends, and therefore you conclude that you're the most likable person ever. No, that's probably not necessarily the case. Or insert other example here. If you say are at a CrossFit gym and you want to know what percent of adult Americans like working out for fun, and you just say, well, hey, I'm here, may as well just ask everybody here. That necessarily won't give you good data for the rest of the population. So convenience is a bad thing to use. Well, like we've already mentioned, we would like to have randomness in a sample, and it turns out you're probably not going to be picking everybody's names and throwing them in a hat to draw. So how could we do this, say, mathematically? Well, to get a simple random sample, we're going to first need a frame. A frame will be a list of all individuals within the population. This is equivalent to writing down everybody's names on scrap pieces of paper. A frame is a list of every individual in the population you want to study. As a little bit of a side note, notice that getting a frame might be expensive in its own right. Therefore, this might not be the best type of sampling for you if that is something you're concerned about. But for simple random, you need a frame. From there, once you have your frame, you will assign each person a number between 1 and capital N. For instance, if I'm wanting to say something about my class and my class size is 25 students, I will first off get everybody's name on a piece of paper, and then I'll assign everybody a number between 1 and 25 in that case, because remember, capital N is my population size. From there, once I have everybody numbered, what I'm just going to do is pick the first N many numbers that pop up, randomly that is. So remember, lowercase n is my sample size. If I wanted 3 out of my 25 people in my class, well, then I would do a random number generator or something to get 3 random numbers between 1 and 25, maybe like 18, 3, and 6. And whoever had those numbers, great, you're in my study now. It's very similar to picking names out of a hat, just now we're throwing numbers on. That way we're putting it in the language of computers. Now, another important distinction that's going to come up in this section will be to replace or not to replace. So let me dive into what the slide says, and then I'll compare it to something that makes it a little easier to remember. If when we choose an individual from the population to be in a sample, if that individual is chosen and then placed back in the population and is eligible to be chosen again, you have sampled with replacement. You took that individual out, sampled them, threw them back in, so you replace them back in the population, they're allowed to be chosen again. If, however, once you take an individual to be in your sample and you don't want to include their same opinion all over again, well, then you sampled without replacement. Now, this is very similar to fishing in my mind. When you go fishing, if you catch a fish, you have the option to either throw it back, sample with replacement, or you have the option to keep it, which would be sampling without replacement. Now, typically when you're getting humans' opinions or trying to study something in humans, you're going to be sampling without replacement. For instance, I don't want the same individual's opinion over and over and over again as to whether they like Taylor Swift or Beyonce better. I want to get everybody's opinion on that. So it's not worth just hearing the same answer and over from the same individual. However, when you're doing an experiment like, say, hey, what are the first 10 numbers to show up when I roll this 6-sided die? Just because you roll a 1 once doesn't mean you should throw it out. That would be sampling with replacement. I'm allowed to pick that 1 again. Now, we're going to come to somewhat of a conclusion on the chapter by showing you a way that has been used to keep it random. So, since randomness is very essential in our studies, we really want to guarantee that, we get pretty nitpicky as to how we get these random samples. One way, if we involve numbers, is we can use a random number generator. Now, this is just a program on your computer where if you hit enter, it will give you a random number between 1 and whatever number you pick. So, if you have access to a random number generator, here's what you could do. First off, develop a random array, meaning a random table, of numbers via a computer generator. These numbers will be numbered 0 through 9. So, hey, you can have 10 possible digits right here for each cell in your table. Once you have that random array, what you'll do is you'll determine the size of the population, call it capital N, and your sample size, call it lowercase n. Once you have those numbers, you will create a frame, meaning that list of individuals, by developing a list of all members in the population. So get all n many members, capital N, in your population listed. Now, what you also want to do is number all of them. So that's kind of implicit in me saying get a frame. It means you have a list of everybody in your population with numbers associated to them. Now, once you have that frame and you also have that table, separate things, what you'll do is you'll pick a random starting point on that table by chance. Kind of hard to do it perfectly, but maybe you close your eyes and you drop your pen on the table and boom, you hit a number. Once you have a starting point, the first lowercase n many numbers that you run into will be the first, the individuals that are picked for your sample. This seems very confusing. Let's go ahead and go over an example of what I mean. Say a community college has 7,657 students currently enrolled in classes. To gain the students' opinions about an upcoming building project, the college president wishes to obtain a simple random sample, of 8 students. He numbers his students from 1 to 7,657. Now I could just start doing that 1, 2, 3, 4, ... And maybe I have a bunch of dots in here. I'll show a middle row. Let's say 266, 267, 268. Whoops, I did that horribly. I don't have any erase. Sorry. 268. ... You have more in here, and then ultimately you have 7655, 7656, 7657. Hey, we made it. And next to all these numbers is a name, so every single number means a certain individual. Now, by the way, in order to make these numbers more uniform looking, notice the first column only has 1 digit, the second column has 3, and the last column has 4. Let's just add zeros to the starts of these guys on the left hand and in the middle columns to make sure everything is 4 digits long. So the number 0001 means the number 1. The number 0267 means the number 267. And notice no zeros required because I already have 4 digits on my far right hand column. Okay, great. We've numbered everybody in our population and the numbers are uniform looking, meaning all numbers are 4 digits long. This president then generates the following random number table and drops his pen randomly on the digit in row 2, column 4. So row 2, column 4 is a 6 right there. Using this as a starting point and proceeding downward, determine the number of the 8 students who will be included in the sample. Okay, so starting at 6. Now remember that we numbered students using 4-digit numbers. So just the number 6 isn't valid. Since we picked 6 as a starting point though, our first student will be number 6751. Cool. If you're that student, great. You're in the survey. Now since it said to proceed downward, we'll go to our 8. And our next student will be 8511. If we go downward, we'll have student 0464, which is just 464. Keep going, we'll have student 1784. Keep going, we'll have student 3017. And oh crap, we hit the bottom of our table. Well, you guys can probably imagine what to do. Let's go ahead and just bump up a little bit. So let's go back up to here now to start off, giving a student 3389. Okay, great. We got 1, 2, 3, 4, 5, 6 students now. Notice the next student would be number 9797. But oh crap, there were only 7,657 students. So we actually throw out this whole number because that's not an actual student number. Leads us to our next student, 4062. And last but not least, our last student will be 0765, which is student 765, and bam, there's your sample. Yes, it seems a little bit overcomplicated, but hey, as you guys see, it works. The big thing would be to number each student in a uniform manner, all 4-digit strings in this case, and then pick a random starting point, throw out numbers that don't make sense, like 9,000 here, and then just get 8 unique numbers in this case. Begs a question. What if the president used that random number table and did the following numbers for 8 students? 5146, 5782, 3727, 3549, 1338, not a problem so far, 5782, wait a second. Notice that we've already picked that number. Since we're doing people, we would want to sample with or without replacement. So if you just so happen to come across the same number, not a big deal, just chunk it. Do not include that one. So hey, our numbers will be 5146, 5782, 3727, 3549, 1338, 6522, 4883, and 779, I believe. 1, 2, 3, 4, 5, 6, 7, 8. And hey, we don't need this one because notice that we have 8 now. So the remainings without the X's will be the students selected. You do not select repeats when it's humans. Notice this will be the end of 1.3. This is all about randomness, and randomness is very important. Next section we'll be diving into what happens when maybe, what are other forms that we can do? Like maybe you don't want to do simple random, or maybe it's expensive to get that frame. In the meantime, focus on getting your simple random samples. Focus on working on those number tables. Best of luck to you guys. Reach out to me with any questions. Thanks.